All right, so notebook 3 is visualizing statistical relationships. So this is was recently changed in the new version. So it's still new to me, but it's basically the same ideas as before, but they've kind of consolidated and added some functionality. So there's two main functions or plotting functions that are provided. So there's scatter plot and line plot, but these can both be kind of done using kind of a higher level function called rel plot, which is a relationship plot, and that has within it the ability to set kind equals scatter or kind equals line. But the idea is the same. So let's do what I didn't do before and restart and clear output. And we're going to do a couple things. We're going to import NumPy pandas, matplotlib, Seaborn, and then set the style. So we saw before there's a set style function. There's also within set, you can do sns.set, and then inside that you can say style equals, and then you can set other things at the same time. So there's different ways of setting your kind of overarching settings for your plots. Okay, so scatter plots are super useful ways of showing data, and in Seaborn we have a lot of options to provide additional categorical data to make our plots more informative. So in these examples, we're going to use a data set called tips. So this is, we're just looking at the first 5 rows of this data here. This is bill data and tip data for people at a restaurant, and it has information about their gender or their sex, whether they were smokers or not, the day, the time, which is which meal, and then the size of the party. So we can use this data, all this sort of metadata or categorical data about the basic data, which is the tip and bill data, to learn more about this data set. So if we plot a rel plot, by default it's going to generate a scatter plot. So we're going to see, and the way that we do it in Seaborn, so in matplotlib you'll specify your X data and your Y data, and so you would do like your data frame column as your some column from your data frame, say in your pandas data frame, as your X data, and then some other column as your Y data. In Seaborn, you specify the data as an additional argument, and then the X and the Y are columns in that data. So you'd say X is your total bill and Y is the tip, and then the data is going to be the tips. So it then knows that this data frame has all these columns in it, and it understands that these are columns in this data frame. So so this is nice, but the nice thing about Seaborn is it has a lot more functionality that we can use. So we can specify the hue as smoker, and what this will do is it will take the data and color it by whether that person was a smoker or not. So we can see that it doesn't appear to be a big pattern based on that, but it'll color automatically by that. So now we've already added in extra information that we didn't have before. In fact, in addition to the hue, we can also set the style, which is the marker style. And now we will see both the color and the shape of the markers are different. So it gives an additional emphasis. However, if we wanted to, we could specify not just the hue, but we could specify some other category. So we'd have the hue as smoker, and the style would be time. So if we run that, we see we now have colors specify smoker or not, and the shape specifies the time, whether it was lunch or dinner. So from this data frame, now we're able to see not just the data itself, but two additional categories. Very simply, just using a single command. If we were to do this in matplotlib, it would be a lot more work to get to this point. If we specify the hue as a numerical category, it'll understand that rather than categorical, we can specify as continuous. So now we'll use a color map to show the range from low to high. So this is one of those sequential color maps that's really handy. And we can specify the palette directly in the command. So this now we can use this fancy kind of this fancy categorical color map. If we want, we can also we also have, in addition to hue and style, we have size. So the size of the marker can also change. In this case, we're using the same colors for each, but the size of the party is indicated by the size of the marker that we use. And we can also specify a range of sizes from low to high. Okay, so that's scatter plots. Using a scatter plot using this relplot function. Relplot can also be used to show a line plot. So we can specify the kind equals line, and this will give us a different kind of plot. One where maybe we have a more of an obvious sequential relationship between the x and the y. So for example, here we have a data frame where we have time and value, and we want to plot the value as a function of the time. So it makes more sense to have this as a line than as a scatter plot, because there's more of a relationship between consecutive points on the x-axis. We can flip the axes if we want, but this won't work as well because it's going to try to connect consecutive x points. So typically you would want to have data more in this format if you're using a line. So there's some things we can do with things like confidence intervals. So here we have we can aggregate multiple measurements at each x value and plot the mean and 95% confidence interval. That's the default behavior. So this is showing a 95% confidence interval. And we can turn that confidence interval off and just show that mean. This would show the standard deviation instead. Or we can avoid the estimator, but now we're going to see kind of strange zigzag pattern where it's trying to connect points that maybe shouldn't be connected. So here we can, we're still using a line plot, but now we can separate it out by event. So this gives us some additional way to control how the data are aggregated, and maybe more meaningful because there's actually two signals here. And we can provide additional, instead we can hue by region, and so again we're just adding additional metadata information from our data frame, which is up here. So we've got all these extra metadata categories that we can use to kind of pull out different features from the data and use different styles. So lots of different options for customizing. Okay, I'm going to go through this. So this next example is a different data set of, it's called dots, and there's, again, we're specifying an X and a Y, a hue, and a style. And then it's using the color map that we have as it's the way it's coloring. And this is a way to change the coloring pattern a little bit using a logarithmic scale. So here we're adding now an additional category, size. So we're now using, instead of color, we're using thickness of the lines. And using different colors as well. So lots of ways to customize how we're using our metadata to color these line plots or these scatter plots. If we have date data, we can generate a figure, and Seaborn has this auto format date to automatically format those in a reasonable way. So that's really handy. We'll talk a lot more about timestamps and date time objects as we go forward. We can also deal with multiple semantic data in the same figure. So in this case, what we're doing is we've got this facet grid, which it understands that the data it will represent the same data set in multiple ways on a grid, so that it automatically, in this case, will generate 4 plots. So we have our X and Y data. So we have our X data is time point, our Y data is signal, our hue is subject, which is specified by these colors. But then we have column and row. So what column is it's these columns of the subplots and it's generating all this automatically. So the column is region. So here, and it automatically goes into the title here. So the region is parietal on this one. This is fMRI data. And on the second column, region is frontal. And then we have row as event. So here event is stim. and then the second row of event is Q. So what it's doing is it's showing the same data, the same x and y axes, but different subsets of the data in these different subplots. So it's a very, very sophisticated and an easy way to see lots of data that are related in a single figure. So this kind of grid is called a facet grid, and it signifies that we have different parts of the figure that all can kind of talk to each other. This is the same idea here. We just have, instead of having multiple rows, we only have one row. We have multiple columns by subject, and we can specify this column wrap equals 5, so we can wrap these around and only have a width of 5. So just a way to control the output a little better. And it automatically controls the labels and stuff for us. So it's really, you might want to do something more sophisticated with Matplotlib and have more control, but for a lot of things you can really get a lot done with these very simple commands to do something quite complicated.